A very good evening to each and everyone who is listening to this pitch. My name is Niluk Sharma. I am educationally I am a law graduate, and I have certifications from multiple universities and institutions, including IBM, International Business Mechanics, Colorado University, Cisco Networking Academy on cybersecurity, and also I have certification from PXA, Coursera, and various other institutions which you can verify on my LinkedIn profile. I've also included my resume biodata in the link in the description below. You can click there and find my online portfolio, per se resume or personal website on that link. So the main thing that I would be talking about in this video is about our new project called Garbage to Go. Garbage to Go. Initially, I had conceptualized it as an overall waste management solution, including plastics, bio waste, medical waste, and many other waste. That we can even think that we as humans can generate and we can possibly think of. But now, I realized after close research and depth research for the past 5 years, I came to know and realize that it is literally not possible for an individual or for a corporation to literally cater to all of the waste generated by human beings. And so I choose to target one specific niche, which is e-waste, and particularly e-waste is something that is going to increase in number in a multifold manner. So the project Garbage to Go's motto would be fixing the e-waste problem of India. And this project has been compiled and would be executed in partnership with another co-founder to this project, which is Mohsin Mondal. And as you can see here, I have written fixing the e-waste problem of India. But when we say e-waste problem, it doesn't mean that e-waste problem is only in India, and the e-waste problem of India does not have implications on the global climate change or environmental pollution in general. So if we get successful in fixing e-waste problem of India, we are indirectly and also directly contributing towards the SDGs, Sustainable Development Goals 2030 of the United Nations, and also, sorting and fixing multiple use cases of e-waste, specifically through restoration, reuse, and recycling. And that would, not only enable us to establish a circular economy system, but also at the same time reduce the amount of pollution that had been generated through unorganized e-waste recycling units that are in India. So what happens, usually in India as we deep dive into the actual market, we found that 80% of e-waste are being collected by unorganized sector, and 20% contributes towards the organized sectors, that is established firms, established and registered license e-waste collectors. But then the problem arises there. There needs to be more and more of such e-waste management companies, e-waste management or recycling corporations, which have the license and authority to sustainably process those e-waste and convert them into reusable, recyclable, or restorable products that they will contribute toward reducing climate change, and they will contribute towards a sustainable future. Yeah, so that is the main target goal of Garbage to Go, Project Garbage to Go. And in this, so the file that you are seeing here is actually the business performer or project performer per se. And this is the index that you can see. I have highlighted 8 main points: project details, problem analysis, implications and SDG alignment, financial layout, research and analytics, future projections, AI and data monetization, and conclusion lastly. So yeah, let's start with project details, what we are going to be doing here. So in the report, I have mentioned here that India generates 3.2 million tons of e-waste annually, with a 30% CAGR in electronic waste production, which means by 2030 we are looking at least in a five years period. 5 into 3 is 15, so 150%, which is as you can see 3.2 into 150%. That's going to be more than 350%. Sorry, 350 million tons, right? Which is a lot, and that might possibly have immense health impact and also on the environment as well. So India generates 2.2 million tons of e-waste annually with a 30% CAGR in electric waste production, driven by rapid digitization and disposable tech culture. The problem, that I have put in here by the term disposable tech culture is that most of the tech companies and producers, manufacturers, including all those smartphone manufacturers, they tend to produce smartphones. They tend to design smartphones in such a way that it is, made non-recyclable. You cannot, or per se non-repairable. I can't say non-recyclable. It is recyclable, but it is non-repairable. So once a device gets, gets out of its lifetime, you usually have to throw it away, or basically buy a new one, which in turn puts up to buying and producing more and more phones, and and piling up of e-waste in landfills. This proposal outlines a scalable, socially inclusive model to transform e-waste from devices with processes, smartphones, wearable PCs, etc., into economic value while addressing environmental and health impacts. So there is a reason behind choosing smart devices with processors, because when we look at PCB boards in most tech-related products, consumer products, we get to see that there is not much of a value when it goes to scrap. But if there is involvement of processes, which the likelihood of us getting gold from those processes is really high, and also silver, the amount of silver and gold from all of those processes is really worth it. And you don't have to. It does also conserve the environment in such a way that you don't have to go mine those virgin mineral elements to produce new smartphones or new smartwatches. Yeah, so that is basically the point. And into economic value while addressing environmental and health hazards. Project details objective. The primary goal of the Garbage to Go project is to establish a circular economy system, specifically targeting processor-based e-waste. This initiative aims to create a sustainable model that not only manages e-waste effectively but also generates economic value through recycling and refurbishment. The key components of these objectives include decentralized collection. By employing a network of 1,000 independent scrap collectors, we will facilitate the efficient collection of e-waste from various reasons. These collectors will be incentivized to gather e-waste at market rates, ensuring a steady supply of materials for processing. With the first word, decentralized collection, let's talk about it. So, as I was, drafting this project performer, I realized that instead of collaborating with the already existing Kawadiwalas, we can actually set up independent train, because we are specifically dealing with those devices which has processors. We need to have specialized trained collectors who can actually procure our raw material that is e-waste with processors from which would be posted at multiple locations inside of West Bengal, inside of Jharkhand, inside of UP, inside of Orissa, and all the other neighboring states, including Assam, and also Andhra Pradesh. So 5 states is where we would be deploying these 1,000 decentralized collectors, and we'll see how the project scales. As the project scales, we will also try to increase the number of collectors, and probably we would go up in number to 5,000. But these collectors will be incentivized to gather e-waste at market rates, ensuring a steady supply of materials for processing. So multi-stage sorting is the second step that comes in after the collection of scraps, e-waste. In this stage, I don't think it is good to call scrap. It is not actually scrap. I don't usually see e-waste as scrap. It's not actually scrap if you can comply with the RRR principle, triple R principle, a multi-stage sorting. So the collected e-waste will undergo a rigorous sorting process divided into 2 tiers, Tier 1 and Tier 2. In Tier 1, sorting by device type, example smartphones, laptop, smart home appliances, and so on. And Tier 2, quality grading based on refurbishment, refurbishment potential, scrap value, basically meaning that if, say, for example, there are 1,000 phones in our collection system, and of them, 500 of them are worth refurbishing and can be repaired and sold in the market as a refurbished mobile phone. So we sort them out as a separate category, and then those devices, those mobile phones which are not worth refurbishing, but you can basically extract those components and sell the components as a component and not really as a phone. That does also work. Or you can use those components to develop new tech, since say mobile phone developed design and launched on 2024 would basically have those technical hardware capabilities that can create other tech-based products, and that not only help us scale in terms of R&D, but also help us develop new products using those component or parts of those e-waste. And the last category would be pure scrap, which I would say it would go directly into the scrapping process. So the first part, refurbishment and component recovery, we aim to refurbish 20-30% of the collected devices for resale while recovering valuable components from 60 to 70% of the waste. So if assuming 20 to 30% of the collected devices are refurbishable and can be resold on the market as a refurbished item, that is really good. And also at the same time, we would be trying our best to extract all of those components, that is from 60 to 70%, including those which has no refurbishing capacity, and try to sell those as separate components or as or will be reused in our R&D department. This dual approach maximizes resource recovery and minimizes environmental impact, because companies and corporates does not really have to remanufacture those cameras, those speakers, those PCBs, or those screens if we have the capacity to recover those components. And then the third process that comes in is data-driven research. The project will leverage data analytics to inform tech innovation and policy advocacy, ensuring continuous improvement in e-waste management practices. Up to here, it's understandable and pretty much easy. Now, coming to target devices, what devices we are really into. So there are basically three main categories. The first category would be personal tech, which includes smartphones, laptops, and smartwatches. It's not only smartwatches, also smart anything, smart wearables, smart glasses, smart rings. Now recently in Shark Tank India, I saw technology where you can pay with a ring. It's basically like wearing a ring, and those kind of technologies, can be put into this category, personal tech. And then comes the home appliances. Under home appliances, we may include smart speakers, IoT devices like Alexa. And then comes hardware. Hardware part, specifically these are from PCs and laptops, specifically those graphic cards, processors, and screens, TV screens, LED screens, or monitors. These categories encompass a wide range of devices that contribute significantly to e-waste innovation. Operational workflow. Okay. Now that we have discussed about our target devices, let's move on to operational workflow of this Garbage to Gold project. So the operational workflow of the project is designed to ensure efficient processing and maximum recovery of valuable materials. So the first part, as we have already discussed, collection. E-waste will be procured through our network of independent scrap collectors, who will be trained to identify and collect processor-based devices at competitive market prices. Sorting. Tier 1 sorting, Tier 2 sorting that we have discussed already, refurbishment process that comes up next. Then comes component recovery, and the last process would be the scrap processing. The remaining materials. So since we have discussed all of the above processes, let's discuss the scrap processing. The remaining materials, primarily metals and plastics, will undergo mechanical recycling process to recover valuable raw materials while ensuring environmentally sound disposal of hazardous materials or substances. Importance of circular economy and e-waste management. The main goal of each and every government, the main goal of each and every individual firms that deals with e-waste management need to understand why creating a circular economy is a must. So the transition from linear economy, tech, make, dispose methodology to circular economy is critical in addressing the challenges posed by e-waste in India. The circular economy encompasses resources efficiency, product reuse, and material recycling, which are essential for sustainable development. By adopting circular economy principles, we can significantly reduce pollution and waste associated with e-waste disposal. And then, thirdly, implementing effective recycling systems can recover precious metals and materials that are often lost in traditional disposal methods. And then lastly, encouraging manufacturers to design products with recyclability in mind fosters longer product lifespans and reduces overall consumption. Okay, conclusion. I don't need to talk about a conclusion here. So we would have a combined conclusion in the last piece. So now that we have talked about the product details, now let's look at the problem analysis. So the problem analysis part, is really interesting. So key challenges addressed. Informal recycling dominates. In India, approximately 95% of e-waste is managed by the informal sector, which includes unrelated entities such as kabadiwalas, informal waste collectors. These collectors often resort to hazardous methods like open burning and acid baths to extract valuable materials from electronic devices. Such practices not only lead to significant environmental degradation, but also pose serious health risks to workers and surrounding communities. The informal sector dominance complicates efforts to implement safe and effective recycling practices, which comply with the SDG goals. Health risks. Now, coming to health risks that is informal recycling process implicate on humans. Improper disposal of e-waste exposes workers to general pollution, and the general pollution. Health risks. The improper disposal of e-waste exposes workers and general population to toxic substances, and the general population to toxic substances such as lead, mercury, and cadmium. The materials can cause severe health issues, including respiratory diseases, neurological damage, and various forms of cancer, as you already know, might have heard or not. I will just create another video in detail about the health risks related to e-waste, improper e-waste management. Furthermore, the leaching of these toxins into the soil and water systems contribute to broader environmental contamination, affecting ecosystems and public health. The lack of protective measures in informal recycling operations excavates these risks. And then comes resource waste. So, under the resource waste topic, I have highlighted these points. Despite the growing volume of e-waste estimated at 3.2 million tons annually, only 22.7% is formally recycled. The inefficiency results in a loss of over $1.5 billion in recyclable materials each year. The inability to recover valuable materials such as gold, silver, and copper not only represents a significant economic loss, but also contributes to unsustainable extraction of virgin resources, as I have told you guys a few minutes ago. And then comes the market gap. Where can we get in? Lack of organized players for processor-based devices. Currently, so I think the data here is somewhat wrong. I might need to change it. There are actually multiple players in e-waste management projects, but not specifically into processor based. So I have written here, there's no organized entity focusing exclusively on recycling and refurbishment of processor based devices, which contain high value materials like gold and palladium. This gave the market presents an opportunity for initiatives that can effectively manage e-waste while maximizing resource recovery. The absence of specialized players means that most of these valuable materials is lost in informal recycling processes or sent to landfills. Limited infrastructure for refurbishing premium gadgets. So the existing infrastructure for refurbishing high-end electronic devices such as GPUs, laptops, and smartphones is inadequate. While there are authorized recyclers in India, their capacity is insufficient to handle the growing volume of e-waste generated each year. The lack of facilities dedicated to refurbishing premium gadgets limits the potential for extending product life cycles and providing affordable alternatives to consumers. Good. Addressing India's e-waste crisis requires a multifaceted approach that tackles the challenges posed by informal recycling practices, health risks associated with toxic exposure, and significant resource waste due to low recycling rates. By establishing an organized framework for processing e-waste, particularly for processor-based devices, this project aims to fill critical gaps in the current market landscape while promoting sustainable practices that benefit the environment and public health. Effective collaboration between formal and informal sector aligned with early-based infrastructure development will be essential in overcoming these challenges and creating a circular economy for e-waste management in India. Okay, then that comes the let's talk about the implications and SDG alignment. Implications and SDG alignment. Talking about implications and SDG alignment, let's start with environmental impact. So, pollution reduction, how various projects, various goal would help in fighting pollution. So the formal recycling of e-waste is crucial for mitigating environmental pollution. It is estimated that organized recycling efforts can prevent over 500 tons of toxic leakage annually. By processing e-waste in a controlled environment, harmful substances such as lead, mercury, and cadmium are managed safely, reducing their release into the air, soil, and water systems. This not only protects the ecosystem but also minimizes health risks associated with toxic exposure. Then comes resource conservation. So, recovering valuable materials from e-waste contributes significantly to resource conservation. For instance, the recovery of 1 ton of circuit boards can save approximately 1.5 tons of mine ore. This process reduces the need for virgin material extraction, which is often environmentally damaging and energy intensive. By promoting recycling and refurbishment, we can conserve natural resources and reduce the carbon footprint associated with mining activities. And then comes the socio-economic impact where this project comes to goal would imply. So the first and foremost is job creation. As we have talked on it earlier, we are engaging 1,000 plus decentralized e-waste collectors, and also 150 plus jobs, direct jobs. So let's have a look at it. The project is expected to generate substantial employment opportunities, creating over 150 direct jobs for collectors and technicians involved in sorting and refurbishment process. Additionally, it will provide more than 1,000 indirect roles in associated sectors such as logistics, sales, and customer service. This job creation particularly significant in urban areas where e-waste generation is the highest, contributing to local economies and improving livelihood. Yeah, so just taking out this part, this job creation is particularly significant in urban areas where e-waste generation is highest. So this specific line, I have put this in because as I was researching about the market, I realized that UP, Uttar Pradesh, and West Bengal, tier 1, tier 2, and tier 3 cities, I realized that depending on based on the population size and the user approach towards technology, users approach towards smartphones and small devices, I realized that the maximum number of e-waste generated in India is from UP and states like West Bengal, where population density is high, and for West Bengal the population density is high, and for UP overall population is the highest from among all of the Indian states. So assuming even one smartphone for one household, which is not also in the high-end range, we are talking about those smartphones within the range of 5,000 to 10,000 rupees a device, and those smartphones does not even last for a year or two. So what they do is basically use it for 1 or 2 years and then switch on to another one after it goes. It becomes unusable, and that is really a sickening thing. We have to talk about. We have to be aware of. So the amount of waste generated in states like UP is phenomenally really high for India. And then comes coming back to the topic, socioeconomic impact. We have to talk about job creation. Now let's talk about affordable tech. Affordable tech. By refurbishing electronic devices, we aim to provide affordable technology options to consumers. So, for example, states like UP, as we were discussing, users don't have to buy, those low-end devices where they have to throw away every year, every 2 years, and buy a new one. Instead of doing that, if we could provide those high-end devices at a lower rate, then the chances of people buying new phones every year would significantly reduce to a phenomenal level. So refurbished devices will be sold at 30 to 50% discount compared to new products, making technology accessible to a broader demographic. This approach not only bridges the digital divide, but also promotes responsible consumption by extending the life cycle of electronic products. SDG alignment. Now let's come to SDG alignment. So the Harvest to Goal project aligns with several United Nations Sustainable Development Goals, SDGs, highlighting its broader impact on sustainability and social equity. SDG 12, responsible consumption. First one, the project aims for a 50% recycling efficiency for targeted e-waste, promoting sustainable practices in consumption and production. And then SDG 8, decent work. By formalizing informal waste pickers into a structured system with fair wages and safe working conditions, we contribute to decent work opportunities for marginalized communities. And then SDG 9, innovation. Establishing an R&D lab focused on component reuse and tech prototypes for innovation in recycling technologies and product development. Yeah, that I have already talked about earlier. But what needs to be understood is that we are catering to 3 specific SDG and also at the same time contributing towards climate change, the fight against climate change. Then the financial layout. I don't know if I should be discussing about this one. So the initial investment breakdown that I have come up with is basically 7 crore rupees. It is in rupees, so almost around $800 to $900,000. Scrap collector network 2.5 crore would be required to cover onboarding 1,000 collectors, training and logistics. Specifically because they are located at distributed locations, and transportation and logistics from those defined locations would cost us a lot and initially. So yeah, from that perspective, we are allocating 2.5 crore, and then sorting machinery that would cost us 1.2 crore for semi-automated conveyor belt, AI-powered sorting tools, and safety gears. Refurbishment setup 1.8 tool for device testing, replacement parts, and workspace setup. That doesn't have to be a separate department, but I am planning to set it up as a separate department because the sorting part and then the refurbishing part is totally a different approach that we need to that needs to be separated as departments. Then comes the R&D lab. For the R&D lab, I am allocating 1.5 crore for equipment, for material analysis, prototype development, and data analytics software. We can hold on to the R&D lab for the initial phase of the project, and we can start integrating it in the second year of the project, because in year 1 the main goal should be to actually establish those successfully implement this project, and R&D comes later on. So the first and foremost thing is to set up the factory, and total cost that I have highlighted over here is 7 crore rupees. And then Then comes the revenue streams for this G2G project. I'll herein forward, I would, hereinafter, I would be calling Garbage to Gold as G2G. So the first one is refurbished cell. Target devices, premium laptop, GPU, smartphone. Pricing, refurbished laptop 25,000 to 1.2 lakhs per unit, depending on specs. GPUs 15,000 to 60,000 per unit, NVIDIA RTX 3060, 4090, and then T100, H100. There are multiple of them. And then smartphones 5,000 to 30,000. So with a volume of 500 to 800 devices per month post year one, and annual revenue is estimated to be 6 crore to 9.6 crore, assuming 600 devices per month at an average of 1 lakh per unit, which is a lot, but yeah. And then comes component resale. So key component that we will be dealing with here is batteries. So 200 to 1,000 rupees per unit. Processors 500 to 5,000 per unit. Screens 1,000 to 8,000 unit per unit. And then volume to 20,000 to 30,000 components per month, which is indeed a lot as compared to the number of devices that we have refurbished, because only 25 to 30% would be refurbished, and then other than that, the remaining part would be going for the scrapping process. So instead of directly sending them to scrapping, before that we would like to make sure that the components are reusable. Check whether the components are reusable, and if yes, then we would extract those components, and then the remaining part would go for scrapping. And then comes the scrap metal recovery, where materials gold 5 lakh per kg. That is the market price, and then copper 700 per kg, palladium 4.5 lakhs per kg, yield 1 ton of waste, e-waste equates to 150 to 350 gram of gold, 1 ton is 1,000 kilo, and then 200 to 500 kilo of silver. So the copper. So annual revenue we are targeting here would be 3 to 5 crore. That is processing 100 tons a year with a target goal of processing 100 tons a year. And then we can another revenue stream that we can implement here is carbon credits. So as we process and recycle e-waste, there is this thing called carbon credits, which we can buy from the government. So basically, CO2 offsets we are looking at is 500 to 100,000 ton per year, 500 to 1,000 ton per year. So revenue, it's not a lot, but yeah, it does help. So 5 to 10 lakh per year, 1,000 to 2,000 rupees per ton of CO2. So total project annual revenue for year 3 would be 14 to 22 crore. And then these are the operating costs. So labor 150 employees, 15 lakh rupees. Annual cost would come to 1.8 crore. And then facility rent would amount to 3 lakh per month, which amount to 0.36 crore annually. And then utilities, equipment maintenance, marketing, overall these things would cost us 2.82 crores annually. So EBITDA margin is 55 to 60%. Industry benchmark for e-waste recycling for mostly e-waste recyclers. So funding and grant, we are looking for 50% capital subsidy from Government of India. If we could do that, that would be really good. So 3.5 crore under MO, the EFCC's e-waste rules in 2022 for machine and R&D. PPP model, 1 to 2 crore by a partnership with state PCB units, PCB hubs. For example, Maharashtra's PCB's 10 lakh per ton recycling incentive, it's also applicable because if we are importing e-waste from Maharashtra. Then comes the co-funded grants from Ideal Circular Economy schemes covering 25 to 30% of the project cost. The overall funding, we don't have to even spend a penny to initiate this project. Then financial protections, that we have talked about it already. Then comes the risk mitigation. So in case of price volatility, there may be risks. In case of demand uncertainty, there may be risks. In case of regulatory compliance, there may be risks. So we might have to allocate certain funds for EPR certifications and audits, which is 20 lakhs per year, assuming there is regulatory compliance coming up, unexpected regulatory compliance, and also the mandatory regulatory compliance that we need to follow up, as a e-waste recycler, e-waste management company. Then comes the research and analytics. So the most interesting part and the thing that makes Coverage to Gold a unique project would be this part, research and analytics wing. Not wing really, not row, but yeah. Data collections, effective data collections is fundamental to optimizing the workflow of e-waste management. By documenting restoration process, we can identify inefficiencies and implement improvements. Key strategies include workflow documentation. Each step in the refurbishment process would be meticulously recorded, allowing for analytics of time, resource, and outcome. This documentation will help pinpoint bottlenecks and streamline operations. Real-time monitoring. So, utilizing technologies such as GPS tracking and inventory management systems can provide real-time data on collection routes, processing time, and material recovery rates. This information is crucial for adjusting operations dynamically to enhance efficiency. So, material recovery database, establishing a comprehensive database to track the yield rates of precious metals recovered from e-waste is essential for assessing the financial viability of the recycling process. In this database, we'll track recovery rates by documenting the quantity and type of materials recovered from each batch of e-waste. We can analyze trends over time. This data will inform decisions regarding processing methods and resource allocation. And then comes the market analysis. The database will also facilitate market trend analysis, helping to determine the most economically viable materials for recovery and resale. Understanding fluctuations in demand for recycled metals will enable better pricing strategies and inventory management. Then comes policy advocacy. To ensure the long-term success of the project and improve the regulatory framework surrounding e-waste management, partnership with institutions such as the Institute of Technology, IITs, and National Environmental Engineering Research Institute and NWERI will be pursued. This collaboration will focus on proposing amendments to e-waste rules 2022, engaging with policymakers to suggest necessary changes that enhance compliance, safety standards, and operational efficiencies in e-waste recycling. That is where I would like to, deep dive into, and where my mindset, clicks. But yeah, we'll talk about it later on a separate video. Oh yeah, then coming back to the topic now, research contributions, leveraging academic research to support evidence-based policy recommendations that address emerging challenges in e-waste management, such as technological advancement and changing consumer behavior. Current trend in the e-waste management, I don't think, okay, so yeah, current trends in e-waste management. The integration of advanced technologies into e-waste recycling processes is becoming increasingly vital. Current trends include AI and predictive analytics. Implementing AI algorithms can optimize collection routes based on historical data, predict waste generation patterns, and identify market trends for recycled materials. This predictive capability enhances operational efficiency and resource management. Enhanced safety protocols. Enhanced safety protocols. Where is that? Yeah. Enhanced safety protocols. Advanced technologies can also improve safety measures while detecting hazardous materials during processing, ensuring compliance with environmental regulations. Hub and spoke model. This model facilitates. Hub and spoke model. What does this do? So this model facilitates efficient processing by centralizing collections at a facility before directing components to specialized bespoke facilities for further processing. This approach maximizes recovery rates while minimizing waste. Then comes future projections for Garbage to Go. Before we go to future projections, I would like to talk about the data monetization strategy, because this is more important. So, yeah. So we were talking about documenting and filming the whole refurbishing process. The reason behind that is not only about analytics. It's not only about market trend analysis using AI, but also you can actually use those data to actually train multiple AI models, and also train and also can those data and those information can be used to train LLMs and AGIs to that can automate the refurbishing process, that can automate the acquisition and logistic process, and multiple other ways that we can implement those data into, depending on what data we are collecting and how we are processing it. So data collection frameworks have data capture, process metrics, sorting efficiency rates, time per device, accuracy, refurbishment success or failure rates by device category, scrap metal yield percentage, how many metals does the 1 kilo of scrap or 1 ton of scrap produce, and then also visual data, recorded videos of this assembly process for training AI models in robotics and automation that I have talked about now. Then comes material composition data, which would be component lifespan, failure patterns, and material degradation insights. Also, at the same time, apart from all of these, we also get to know and understand, the trend of how companies, producer companies, are actually manufacturing and designing their products, and how users are actually interacting with them. The tool for captures are IoT sensors on sorting machinery, wearable cameras for technicians with privacy circuits, and then comes blockchain-based logs for audit trials. Since this one is the part of the data monetization strategy, we may actually use this data for our own R&D process, and then also at the same time we may sell this data to AI and ML companies. Say, for example, training models for automated e-waste sorting. Then tier subscription, 5 to 10 lakhs per year. Then OEMs, what they are looking for is insights into product lifespan and recyclability. Quantum licensing, 2 to 5 lakhs per dataset. Then comes recycling tech startups, optimizing scrap recovery workflows, per pay per query API access. Okay, and then we might have to develop API structure then for this specific models. Then comes academic institutions, research on circular economic models, premium, basic datasets, free, premium, and 50,000 per year, and like that. Anyway. So yeah, apart from the revenue stream that we have discussed above, this is another way that we can additionally create the revenue and generate revenue from the data that we generate or the whole process. Projected revenue here is 1 to okay, that's a lot of money. API and analytics dominance, 12 crore, 8 crore to 12 crore. Okay, so overall revenue is almost the same as what we get to see in the first phase of revenue models. So see here what I'm referencing to is this one. So revenue generated from all 4 sources of all 4 revenue streams combined is literally equal to the revenue sources generated by a single data-based revenue model. So yeah, This is a way we can double our revenue streams. Then, we were to talk about future projections. So, yeah, expansion to 5,000 collectors. I have already talked about this one. Year three, my main goal would be going from 1,000 collectors to 5,000 decentralized collectors all over India, and they should be spread across multiple key states with higher population density and higher exposure to smart devices. Yeah, 5,000 collectors that we have targeted. Then rationality for expansion. The increase in collectors will facilitate greater outreach in urban and semi-urban areas where e-waste generation is high. By providing training and incentives to these collectors, we can improve the quality and quantity of e-waste collected. And then impact on local economies. This growth will not only create more jobs within the collection network, but also empower local communities by providing them with a sustainable livelihood through responsible e-waste management. And then by year 5, we are looking forward to establishment of regional hubs. So by year 5, the project plans to establish 10 regional hubs, each capable of processing up to 10,000 tons of e-waste annually. That is not that big number. I don't see that as a big number, but yeah, even if we could do 10,000 tons of e-waste annually, that is really good. These hubs will serve as centralized facilities for sorting, repurposing, and recycling e-waste. Operational efficiency, centralizing operations in regional hubs will streamline processes and reduce transportation costs associated with moving e-waste from collection points to processing facilities. We can just leave that aside. The establishment of regional hubs, I don't think that is important at this point now. If possible, as long as we are able to expand the number of collectors, we are actually getting ready to go big and scale. But then regional hubs, from the point of minimizing logistics costs, setting up regional hubs would indeed minimize logistic costs, and then carbon credits. So 5,000 tons of CO2 emissions annually through recycling activities by 2030. Yeah, pretty much good. And then regulatory compliance with India's new e-waste management rules, mandating increased recycling targets 60% by 2030, 70% by 2024, 2023, okay, and 80% by 2025. Our project aligns well with these regulations, positioning us as a compliant and proactive player in the market. Okay, and then let's come back to the conclusion. Garbage to Go effectively addresses India's e-waste management challenges by establishing a sustainable, technology-driven value chain. With an initial funding requirement of 7 crore, the project is poised to mitigate significant health and environmental risks associated with improper e-waste disposal. By year 3, it is projected to generate annual revenue between 18 to 22 crore from the recycling, reuse, and restoration of e-waste itself, and then another 20 to 30 crore from the data monetization strategy that we have discussed a few minutes ago, aligning with India's commitment to achieving net zero emissions and contributing to SDGs, Sustainable Development Goals. The initiative not only aims to enhance the formal recycling rate of e-waste, but also seek to create economic opportunities through job creation and affordable technology access. By integrating a network of independent scrap collectors and establishing regional processing hubs, G2G will play a pivotal role in transforming waste into valuable resources, thereby promoting a circular economy. As the project progresses, it will also focus on policy advocacy and research collaboration to strengthen the regulatory framework surrounding e-waste management. Working mouse. This holistic approach ensures that a project not only meets immediate operational goals but also contributes to long-term sustainability and innovation in waste management practices across India. Yeah, that was basically the whole project performer for Garbage to Go or G2Z, Project G2Z. But yeah, I would also be creating, multiple videos related to this in the upcoming videos. So make sure you check out the playlist, the whole playlist. I will be creating a separate playlist for this project, and you can deep dive into it. If you want, if you are into e-waste management, if you are a student, if you are into environmental protection, if you're into climate change, if you have anything, if you want to know anything related to e-waste management and how e-waste have what impacts does e-waste have on humans and the environment in general. So yeah, and there would be separate videos on separate topics, but this was the project portfolio that I have created. If you like the content, if you think you want to be part of this process, do comment, or you can directly send your details on my email, which I have provided in the link in the description. And also you can directly visit my personal website that I have put in the link in the description. And then there is the contact me option. You can click there, and then you can have direct access to me. So yeah, that was the pitch, and that was the business proposal. And let's hope we possibly could contribute towards a successful implementation of Project Garbage to Go, which is targeted to fix the e-waste problem of India and consequently the globe. Thank you.